Thank you, sir. That's great. So now I don't have to shop. All right, so I'm Alan, W6AKB, formerly WB6ZQZ, and I've been a ham for a very long time doing field day, organizing a field day group. One of the things I did a long time ago was to develop a pneumatic antenna launcher because we had some excitement with a bow and arrow. And I won't go into that today, but I wanted something a little safer. Anyway, we're not here to talk about antenna launchers, we're here to talk about 3D printing. And one of the things that I wanted to do was to make a nice spacer. I was using a little block of wood and it was just not working all that well. And I wanted something that would mate with the curvature of the barrel and the chamber and have the right spacing on it. And I decided, 3D printing would be a good way to do that. So I got my first 3D printer, and that began the adventure. That was in, well, it was in 2014. The first printer didn't really work very well, so I ended up getting another one in 2017 and going from there. So anyway, the 3D printer, I have a lot of tools. We all collect tools, right? Isn't that the goal of life? And the 3D printer is the best tool that I have. In fact, I think it'll do half your work. So I bought several, and I'm waiting for it to take over and do the other half. But so how many people here have a 3D printer already? Yeah. So maybe a third.
I got it out of the box.
You got it out of the box. That's a good start.
Next question, is it out of the box?
Is it out of the box? You have 3. I don't want to talk about how many I have. My wife might find out. So anyway, the real purpose of the 3D printer for me is to solve problems, to make things that fix something or solve a problem or whatever. Actually, one interesting example of that is a friend of mine who doesn't live that far away, but during COVID, his gas range knob developed a problem, and they're kind of either expensive or unobtainable to get the knob to fit. But it was during COVID, so we weren't going there, and he wasn't coming to see us. But he sent me measurements, and I sent him parts, and we fixed his oven, his stove. I've still never seen it, and he's, it's a problem-solving machine. And I have a number of examples here today that we can look at. These are mostly ham radio examples. I have lots of other examples, but didn't bring them. So, let's kind of go over some of these examples. So this is a reel. This reel is actually commercially made, but the adapter to make it fit the barrel of the launcher is all 3D printed. The red part in the middle. Now these reels are no longer available, so we replaced the entire thing with the 3D printed part. I made a bunch of HT accessories. These are for batteries and radios. Don't you hate it when your HT falls over?
Yeah.
So the HTs that have good spring clips on them, it's real easy to make a very nice little stand. One of the things that we need to make for antenna launchers are tennis balls that have some sand in them. And we cut a little slit so we can put in the loop to tie the line to. And we have a special little funnel for funneling sand into a little slit. You can't buy that, but it's pretty easy to make one. This is a little tool for holding the ball while you're cutting it with a utility knife. I haven't cut myself. I cut myself with a utility knife a while back, and it's not fun. But I didn't do it with the tennis balls. So this really keeps it from skating around, and if you do slide, you've got quite a bit of plastic to go through before you get to your thumb. This is a little tool for turning the elbow. tightening it and adjusting it, and I also turn it into a die to clean up the threads. And it's hard to grip onto, but this little tool has the hole exactly fit that little elbow. This is kind of a fun one. Who's got a ZM2 tuner? I have a ZM2 tuner, little kit antenna tuner that a guy sells. And for the front panel, he's got a piece of aluminum that's already pre-drilled and a piece of paper that you stick onto it, which didn't satisfy me very much. So I made a 3D printed front panel that has all the writing built in. One of my printers has multiple print heads, so it can change colors. And this also has the standoffs and stuff to mount the internal on the back side.
Nice.
Most of these that I brought here, by the way, are rejects, so if you see flaws in them. This is an interesting little piece. It goes on the launcher.
Why don't you tell them to come back at 11:30?
Oh, 11:30? What?
Come back at 11:30.
Come back at 11:30?
Put that on the sign.
Wrong time slot. So anyway, this is an adapter between the U that goes on the launcher that I make and the barrel. I used to buy a PVC end cap and have to throw it on the lathe and machine it, and then it wasn't really ideal. This fits the tennis ball and fits the U, and it's kind of optimal. So these are a few examples. There's tons of examples of antenna parts, and there's a lot of stuff already on the web that you can download, and you don't even have to design it. I've designed, I think, everything here I've designed, but there's a lot of stuff already out there, so you don't even have to design. But one of the things that you have to do is to choose the right material when you're going to print. So PLA is not, well, it's good enough for certain things. I think this is PLA. It might be PETG. I started making these in PLA initially. And if it gets to about 50 to 60 C, it gets soft and will get soft on you. It doesn't usually melt, but it gets soft on you, and like if you leave it in your car, it'll deform and just be completely ruined. So PLA is what a lot of people start with. It's easy, it's a lot of colors, it's a lot of fun, it's easy to print, but it's not a good choice for outdoors or for vehicle use. What we end up using for most of these things is PETG. This is PETG. PETG is essentially a slight variation on the plastic that they use to make water bottles. So it doesn't really mind the sun. It's a little bit more flexible. PLA is stiff and brittle. So if you need something stiff, it is good until it shatters. This stuff doesn't tend to shatter. It tends to bend, and of course eventually it will crack and break. But now if you're gonna do something with a high RF field, like a coil form, then the best way you really like is something like Teflon, right? Something with a very good dielectric coefficient, something that's not going to absorb any power from that RF field. And there actually is a 3D printed filament that you can use. How many people have heard of 3D printing filament PP? Polypropylene. It's not very common, but you can buy it, and it's available. It's even on Amazon, so it's not that hard to find. The downside, it's actually a very good material for a lot of things. It has good layer adhesion, it doesn't have problems with water very much, and so on. But it doesn't like to adhere to most build plates. So you need to use the right kind of build plate material. And in fact, the box that I bought, which I have yet to try, came with a couple of build plates, sticky, that you can stick on a build plate. So take one of your old build plates, or get a blank steel build plate and stick this on it. So you can have a build plate for polypropylene. But then you can make pretty high quality coil forms and better insulators if you're going to have high voltage RF and things like that. Another one that's popular is ABS. Anybody used ABS? Now ABS requires a warmer environment. In fact, funny story, a friend of mine was telling me, printed some ABS, came out great. And then 6 months later, he tried to print some ABS and he couldn't get it to come out at all. Well, turned out, he got good results in the summer. And in the winter, not at all. He didn't have an enclosed printer and it wasn't warm enough. ABS needs a warm environment to print. So if you're gonna print, if you want to print these more engineering grade materials like ABS, and there's a lot of others, you want a printer that's enclosed. Now if you don't have an enclosed printer, people use garbage bags, cardboard, tape. I mean, you can make an environment that's warmer and draft free, and especially if it's a small thing, you can do pretty well. Now ABS isn't the best in the sun. It'll last for a while, but if you really want it to be out in the sun, ASA is a variant of ABS that's designed with UV inhibitors in it. And in fact, most of the plastic inside your vehicle is ASA. The hard plastic, not the vinyl. So it's automotive grade plastic. Now going up from that, there's another kind of plastic which is so many acronyms. CP, let me look. My fingerprint doesn't match. That's a first. Anyway, yeah, I'm not remembering which acronym it is. It's very much like PETG, but it's a little bit better. And so part of the job when you go to make something is to figure out which filament is appropriate for the use environment that you're going to print. So
are you talking about PC polycarbonate? Is that the one you're looking for?
I think it's PCTG. It's not polycarbonate. There is polycarbonate too. PC and there's some other polycarbonates. I wasn't thinking of that one, but that's a good one also. It's one I bought spools but I haven't used. Mostly I'm using PETG. You can get by pretty well with that. It doesn't require a heated chamber. You don't have to have a enclosed printer. I've done some ABS, printed ABS parts and ASA parts, which do pretty much require an enclosed chamber. So what kinds of things are people printing, or what kinds of things are people wanting to print?
Waveguide?
A waveguide. That's tough.
It's a hollow tube.
Yeah, I know what a waveguide is.
It's
yeah.
conductive.
Right. I would think to do waveguides, you'd print them and plate them. I think that's what you'd have to do. Because for a waveguide, you want really good really good coating. You can't get by with, you know, some carbon impregnated plastic print. Yes?
I don't have anything I want to print yet, but there's a question. A couple of libraries around me have little, you know, areas and you can use their printer.
Printers.
Do I need a better printer? Do I need to buy a better printer, or will they take any of these materials that you talked about?
So library printers, I haven't worked with library printers. What you would probably want to do there to answer that question, well, first of all, yeah, find out the printer that they have, and then go online and look up what that printer can print. They also might have some rules. They might not want people to print something that was difficult just because their technicians wouldn't want to have to deal with straightening the printer out afterwards. One thing is, if you print a higher temperature material, and then the next person comes along and tries to flush out the filament, and they don't set it high enough temperature, that some of your filament might be left in the print head. So, you know, a shared printer, I haven't had that particular experience, but the thing is, I would think PETG would probably be where you want to start. PETG is relatively easy to print. It's a little sticky, so you get a little bit more stringing and whatnot. Typically, you have to print it a little slower than PLA and ABS. The folks who like to print, you know, 3-minute Benjis and the race folks, they use ABS. ABS can print really fast. Yes, sir.
Your polylactic acid, do you have problems with varmints eating it?
Didn't hear the question.
He asked if they had trouble with varmints eating polylactic acid. I haven't heard of that. Anybody have any experience with anything nibbling on your PLA? I've seen people do environmental tests with PLA where they bury it in the yard and dig it up a year later. Nothing ate it. It is possible. It is theoretically biodegradable, but from what I understand, it takes a very high temperature environment to biodegrade it. So your average compost is never going to do it in a reasonable time. So, yes, sir.
What about if you want to print something, do you get the program from somewhere, or do you write it yourself, and how difficult is it to write yourself?
Okay. So you asked about whether you design or write the program yourself. Okay. So there are websites that have millions of designs, and a few of them are actually pretty good. Actually, quite a few. And so your first chore is to, if what you want is something that's likely already been done, dipole center, insulator, I mean, you know, long list, search for it. And there's a search engine, there's several, but there's a search engine for 3D designs called Yeggi, Y-E-G-G-I, and .com, I think. And you go there and you put in some words, and it, you know, they give you lots and lots of examples, little pictures, and you can click on them, and that'll go off to the website where the designs actually are. And so you can download the design file, and then there's the main program that you use with your 3D printer is called a slicer, and there's quite a few slicers out there. And depending which printer you have, typically you'll use the slicer they recommend because they support it the best. But typically you can also use other slicers. And they call it a slicer because it takes a 3D model of the thing you're trying to make, and it slices it into pieces, into layers, because that's how the printer prints it. The printer prints it a layer at a time, and it converts it into a series of, they call it G-codes. It's an old language from CNC machining. And essentially what it does is it tells each motor how to move and each heater how to run. So I mean, a 3D printer is basically a few motors and a couple of heaters. And one motor pushes filament into a hot end that melts it, that's sitting at a certain temperature. And then there's 3 or more motors that position the head and move it around. And there's a nozzle, typically 0.4 millimeters is the nozzle that most people use, but you can use finer or coarser nozzles depending on what you want to do. And so that kind of determines the fine scale that can be in your object, is that 0.4 millimeter nozzle. So if you want to design your own, then you need basically a mechanical CAD program. And the one that most people start with is a program called Tinkercad. It's on the web. It's a website, basically. So you can go there and design stuff with your web browser. I like to use OpenSCAD, which is a free program that you download. And OpenSCAD's a little different than all the other CAD programs. You actually write kind of a program, a piece of code. I want a sphere here. I want a cylinder there. I want a piece of a cube here. And if you want to drill a hole in a cube, you use a difference, and you subtract a cylinder from a cube, and you drill a hole. And it takes a little while. It feels kind of like high school geometry, but it's free. It's unencumbered, and you can do a lot with it. Some people like the real CAD program, and there are some free ones out there that are the programs that you can get free access to. A lot of people really like Fusion 360, so if you want a big learning curve for a program that has a lot of features, you might want to look at Fusion 360. If you get beyond the free stage, it's not free. It's
$500 a year.
it's sucking you in. In the free version, they keep taking away features. Wait 6 months, they'll take away another feature, probably the one you really like, to try and get you to pay for it. So I haven't done the Fusion 360. I've just stuck with OpenSCAD. But there's quite a few other choices out there. Look for some YouTube videos on choosing a CAD program. Find something. Or if you know a mechanical person, talk to them. If you've got somebody that you know that was a mechanical engineer or whatever. I was an electrical engineer, so I missed out on all the CAD stuff, so I never had that training.
What was that name again? Open what?
OpenSCAD.
OpenSCAD. Okay.
Yeah, OpenSCAD.
What was the website, the search engine?
Yeggi, Y-E-G-G-I. And don't ask me what it means. I have no idea. It must be some foreign language. Yes, sir.
A little more of a technical question on the part production. I have a part, same STL file, there is both parts. One guy printed one, his outside surfaces are nice and smooth. The other guy, I get this kind of rough, I can see almost every layer. What kind of setting, is it moving too quickly, or enough heat, or?
So different prints from the same STL file have different appearances and different characteristics in what settings. Slicers are different, printers are different, and there are a lot of settings. And if it's two different printers that aren't even from the same manufacturer, they've made different choices about defaults for those slicers. So making them identical could be a chore. But yeah, so I certainly can't answer your question. No. I mean, there's the slicer I use most of the time is Prusa slicer. I used to use Cura when I got the first printer that really worked. It was a Lulzbot, and they were doing Cura. And then I bought a Prusa. Early days, there wasn't a lot of choices, and Prusa Mark III, and so I started using what has become to be called Prusa slicer. It's called something different then, but Prusa has a whole team of engineers working full-time on the Prusa slicer, which is a free piece of software. It's open software, and so a lot of other companies use that, even though they're not really paying for it. But anyway, a person who's familiar with the slicer software might be able to help answer your question, actually look at it and tune it.
So when we
Yes.
download the design, it's actually defining 3D object.
It's actually a 3D, when you download a design, it's actually a 3D model of what you're going to make. Now, in some cases, some websites will also have printer G-code files, but typically you'd never want to do that. That your printer, it's a little hard to do, but someone might be able to, catch your printer on fire by putting something nefarious in the G-code. So you really don't want to load, and it's probably not going to work very well anyway, because the settings in the slicer involve not only which printer you have, but they involve the filament that you're using. And the filament, there are defaults for each filament. And typically you can use, if the filament you have doesn't have defaults, you can pick another similar filament from another company and it will work. But for example, if you load the settings for Prusa filament on a Prusa printer and a Prusa slicer, they're going to probably be pretty good. And if you do the same thing, for some other filament, they may not be as well tuned.
The G-code is bigger than the model typically.
Is the G-code bigger than the model typically?
That was just a quick
Probably,
question. Yeah.
probably. It really depends. So most of the files that people download, there are many different formats, okay? So most of the files that people download are STL files. And STL files is a file format that predated 3D printing. An STL file is triangles. That's all it is. It's three-dimensional triangles. And so you can imagine the size of that file is really dependent on the granularity of those triangles. And there are programs to reduce the granularity, but depending on where it came from and the program that generated it, it could be crazy fine resolution. So the G-code is motor commands, move, move, move. So they're so different. It's really not practical to compare them. Yes.
For someone just getting into it, what printers would you recommend?
So I have a section in my presentation on printers, and what I was thinking is that I really don't necessarily want to recommend specific printers. I mean, we can talk about that, but in terms of choosing a printer, we already talked about a little bit whether you want an enclosed printer. So depending on what your future goals are for how wide a range of materials you want to be able to print, and whether you want to be able to print some of those fancier materials, you may need a hardened nozzle, or that can typically be changed so that it doesn't have to come from the beginning. But materials that have carbon fiber or glass fiber in them require a hardened nozzle, or the glow-in-the-dark stuff is very abrasive, and then the typical nozzles are brass, and so they're inexpensive and easy to print with. They conduct heat very well. If you're really into production, there are diamond nozzles. There's even a ruby nozzle, and there's hardened steel. But to answer your question, well, one thing, how much do you care about where your printer came from? Some people want made in USA, some people don't care, they just want the cheapest printer. How much support do you want? Do you want to be able to have somebody you can call? Or you want a large community and get community support? That works pretty well. There's a lot of printers coming out of China that are very cheap. Micro Center often has a printer for about $100. I don't recommend it, but just to put a floor on where they start. Bamboos are very popular. I think they have something just over $200 for a printer. Bamboos make a lot of people nervous because to use your printer, you have to log into China, and China gets to look at everything you print. Some people don't like that. Bamboo wasn't around when I was buying printers. I ended up with a Prusa, which is Europe. Now it's interesting, a lot of the motors come from China anyway, but when you buy the printer from Europe, you get a completely different set of support. And Prusa actually has a factory in the US now, so it costs a little bit more. A lot of people like Prusa. Are there some other brands that people want to recommend that they like?
Different topics, I'll let you finish, but.
Okay, thank you.
Creality.
What's that?
Creality.
Creality is another Chinese company, very popular. What?
Elegoo, there's a whole bunch.
Creality? Elegoo. There's a ton of them. Now, another thing which I meant to mention
Anycubic.
is, do you want to print or do you want a printer project? Some people want to just print. Some people want to work on their printer and upgrade it and play with it. So a lot of these very inexpensive printers have tons and tons of upgrades to make them nicer, better. But not everybody wants to get involved in taking their printer apart, and it's like, oh shucks, I forgot to print something I need before I put it back together. I need to put it back together to print that so I can take it apart and upgrade.
That's when you get another printer.
I like that answer.
So, do these printers have processors, computing built into them? Are you driving them with standalone products like Linux, Windows, Pi? What are you driving these things?
So what's in the printer, or what do you drive it with? Okay, it does vary. The majority of printers have a microcontroller in them. Typically these days they used to be 8-bit. Typically these days they're 32-bit microcontrollers, so they're fairly powerful. They don't have an operating system. A lot of them have Wi-Fi, and that's very nice because you can just send your print file through China, and it comes back to your printer. With other brands, you can send it across the room, and that works fine also. You can put it on a flash or SD card and carry it across the room. Sneakernet. So now, some of the printers, like Vorons, how many people have heard of Vorons? So Voron is a design group that designs printers, but they're not a company. And there are a bunch of companies that make kits for the Voron printers. And that printer, and there are a number on the market also that follow the same thing, has a Linux, has a Raspberry Pi type Linux machine, and a microcontroller. But the microcontroller is only responsible for moving the motors, and all the computing and planning is done by the Linux half. And there are some controller boards that have both processors on the board, or a socket where you can put the Raspberry Compute module right in. So it varies. Any printer that uses Clipper, which is what the Vorons use, Clipper's a free printer control software, and it's a very good one. And there are a few printers that use that as well, a few commercial printers. Sobol is a good outfit to look at for kind of inexpensive Chinese printers that use a lot of the Voron technology and Clipper.
What does SCAD run on?
Open SCAD? It certainly runs on Windows. I haven't looked into whether there's version. It's an open software, but I haven't looked into whether it runs on other operating systems. I don't happen to remember that right now. I've been running it for years, and I haven't had the occasion to try that. That's a good question. Look it up on your phone, and you can probably tell us.
So if I could have an imaginary wish list, right at the top would be, hey, I've got this thing, and I want to make another one.
Right. So if you have a thing, you want to make another one, typically it's broken and you can't buy another one for whatever. So what you need is a model. And so one of the tools I use with 3D printing the most is a set of digital calipers for making measurements. You do a lot of that if you're going to do CAD. but even Tinkercad, right? Even a simple CAD, you need those measurements. There are 3D scanners, and you can buy 3D scanner. Well, you can do some 3D scanning with your phone. You take a whole bunch of pictures, and then some software online will merge it. It's not as easy as